Aditya L1 is the first space-based Indian mission to study the Sun from a halo orbit around the Lagrangian point 1 of the Sun-Earth system. The Aditya L1 mission will take around 109 Earth days after launch to reach the halo orbit around the L1 point, which is about 1,500,000 kilometers from Earth. The 1,500 kilograms satellite carries 7 science payloads with diverse objectives. In a milestone in the development of space astronomy in India, the Indian Institute of Astrophysics has built the Visible Emission Line Coronagraph, VELC, the largest payload that would fly on Aditya L1, the country's first dedicated scientific mission to study the Sun. The VELC payload is an internally occulted solar coronagraph with simultaneous imaging, spectroscopy, and spectropolarimetry channels close to the solar limb. Aditya L1 will be able to provide observations of the Sun's photosphere, chromosphere, and corona. In addition, an instrument will study the solar energetic particles flux reaching the L1 orbit, while a magnetometer payload will measure the variation in magnetic field strength at the halo orbit around L1. The other 6 payloads are Solar Ultraviolet Imaging Telescope, Aditya Solar Wind Particle Experiment, Plasma Analyzer Package for Aditya, Solar Low Energy X-ray Spectrometer, High Energy L1 Orbiting X-ray Spectrometer, and Magnetometer. These payloads have to be placed outside the interference from the Earth's magnetic field and hence could not have been useful in the low Earth orbit as proposed in the original Aditya mission concept. Since a satellite placed in a halo orbit around the L1 of the Sun-Earth system has the major advantage of continuously viewing the Sun without any occultation/eclipses, the mission was revised to Aditya L1, and it would now be inserted in a halo orbit around the L1, which is 1.5 million km from the Earth towards the Sun. The scientific studies by the satellite will enhance our current understanding of the solar corona and also provide vital data for space weather studies. Both imaging and spectroscopic observations obtained by VELC payload are key to study the diagnostic parameters of solar corona and dynamics as well as the origin of the coronal mass ejections and magnetic field experiments of the solar corona.